Hello students, today we are going to study Biot law from magnetism. This law states that the magnetic field at a point due to a small element of a current carrying conductor is directly proportional to the length of the element, directly proportional to the current flowing through it, means this conductor, directly proportional to sine of angle between the element and line joining the center of the element to the point, and inversely proportional to the square of distance between current element and the point where magnetic field is to be calculated. As we already know about electricity and magnetism separately, what? Electricity and magnetism separately, but there is relation between them. They are interrelated with each other. What? Interrelated with each other. In 1820, scientist Hans Ørsted found that if at certain region, for example, there is a region like this, at certain region current exists, at this region there is a current, then near this region, or we can say around this region, there is magnetic field. For example, we consider a wire. This is wire. This wire is connected to the two ends of the wire, is connected to a battery. Then this wire carries a current. If current I flowing through this wire is in this direction, then around this wire there is magnetic field. Like if this is wire, current flowing through this is in this direction, then this is magnetic field. These are the magnetic field lines. Circular magnetic field lines. Magnetic field may be in clockwise direction or in anti-clockwise direction. To find direction of the magnetic field, we have different laws. For example, we consider right hand thumb rule. Right hand thumb rule. In this rule, imagine we hold this wire in right hand, then current is flowing in this direction. Then thumb indicates the direction of the current I, and curled finger indicates direction of the magnetic field. Then in this diagram, what is the direction of the magnetic field? Magnetic field is in this direction, means anti-clockwise. But at any point P, suppose this is point P, we can find direction of the magnetic field. How? we already studied how to find direction of the magnetic field. If we draw a tangent to this magnetic field lines, then direction of the tangent shows direction of the magnetic field. But what is the magnitude or value of magnetic field at this point? Means at point P. This problem is solved by Biot-Savart law. Biot-Savart law. This law gives magnitude or value of magnetic field at certain point. Consider a wire carry current I. This is wire which is infinite, and this wire carries current I in this direction. Let P be the point at distance r. From current carrying element, and r bar be the position vector of point with respect to element. Now let us consider small element of wire. dl, because we consider a small element, therefore we can write dl. Through this small element, current is flowing in this direction. Then there is small current element. This current element is written as IDL. dB, there is dB, which is small magnetic field due to small element dl. Let theta be the angle between dl and r bar in the direction of the current. In direction of the current, which is very important. Current direction is what? This, and angle between dl and r. Then this is theta. According to Biot-Savart law, dB is proportional to the I, means current flowing through this conductor or wire, directly proportional to the sin theta, and this dB is inversely proportional to the r square. If we combine all these, then what we get? After combining, we get dB is proportional to the I, as well as dB is proportional to this small element dl. Then dB is proportional to the I dl sin theta divided by r square. If you remove this proportionality constant or replace by k, then what we get? dB is equal to k I dl sin theta divided by r square, where k is a proportionality constant. Value of k for vacuum or air is given by k is what? Mu naught upon 4 pi. This is permeability constant for vacuum or free space. There is difference between permeability and permittivity. substitute this value in this equation. Then we get, after substituting value of k, nu naught upon 4 pi I dl sin theta divided by r square. This is the one form of Biot-Savart law. Now we can write this equation in vector form. In vector form. dB bar is equal to mu naught upon 4 pi I dl bar sin theta upon r square with unit vector r cap. R cap is a unit vector and value of r cap is r bar divided by magnitude of r. As we know, unit vector having value is equal to 1. Then there is no effect on this quantity. If you remember dot and cross products of vectors, for example, consider a bar and b bar are vectors, then a bar dot b bar, we can write this as ab cos theta, and in case of cross product, a bar cross b bar is equal to ab sin theta. Then in above equation we can write dl sin theta into dl sin theta into r cap r square into mu naught upon 4 pi. Substitute the value of r cap. Then what we get? Mu naught upon 4 pi I dl sin theta upon r cube r bar. Substitute value of r cap. This value we substitute in this equation. Then from this we can write dl sin theta r bar is equal to dl bar cross r bar as a cross b is equal to ab sin theta. We compare this to this, we get final result. Substitute in this equation. What we get? dB bar, because we written this in vector form, is equal to mu naught upon 4 pi I dl bar cross r bar divided by r cubed in vector form. This is Biot-Savart law in vector form. This is due to small element. For total magnitude, for total magnetic field at point P, due to entire conductor, we integrate above equation. After integrating, we get b bar is equal to mu naught 4 pi integration I dl cross r bar r cube. This is magnitude or value of magnetic field at point P. Now we find units of mu naught. Units of mu naught. As we know, dB is equal to mu naught upon 4 pi I dl sin theta divided by r square. Sin theta and 4 pi have no units because they are constant. Then rearranging this equation, we get mu naught is equal to dB into r square cross multiplication divided by I dl. Then unit of dB is Tesla. This is distance, therefore meter. We have r square, therefore meter square divided by, this is current, we can measure current in ampere, and again this is small length of wire. Then what? Again this is measured in meter. Then unit of mu naught is Tesla meter per ampere. We can write the unit of mu naught is 4 pi into 10 raised to minus 7 Weber per ampere meter. This is the units of mu naught.